Good afternoon, my intelligent student. This is part of the work that we have been doing earlier before now. So, as we continue, get your paper, get your book, and get ready to start. Now, today, we shall be learning another aspect of this acid, base, and salt. Now, one important aspect is the laboratory preparation of acid. See, very important. Acid can be prepared in various ways, and we shall be looking at these ways. Number one of the ways is by dissolving acid anhydride in water. You may not know what acid anhydride is. I will do another video on that. Acid anhydride. Better still, acid anhydride are the oxides of nonmetals. For instance, example of a nonmetal is carbon. Carbon plus oxygen gives carbon 4 oxide. Sometimes carbon 4 oxide is regarded as acid anhydride. The same thing goes for sulfur. So when you dissolve these in water, it will give you a weak acid. Non-metallic oxides, which are known as acid anhydride, dissolves in water to produce acid. Now, view it very well. Look at this. We have carbon 4 oxide dissolved in water to form weak triisocarbonate 4 acid. CO2 plus H2O go to H2CO3. That is what I was talking about. That is exactly what I was talking about. Let us move on now to the next. Now, preparation continues. This is another acid anhydride, SO3. When you dissolve it in water, it produces H2SO4, but this is risky. Yes, the reaction is very exothermic. It is not advisable to dissolve this, but it's an acid anhydride. Let's move on. Now, to prepare by combination of constituent elements in the presence of specific catalysts. Number one, if you want to prepare hydrochloric acid, all you need to do, just get hydrogen and chlorine in the presence of activated charcoal. You see, when they spark together, they will give you hydrochloric acid. That is through direct combination. But mind you, activated charcoal is the catalyst used in direct combination process of preparing acid. Let's continue. Strong acid and less volatile acid displaces a weaker and more volatile acid from its salt. Look at it. Volatile hydrochloric acid. When an acid is volatile, it can easily escape. It can easily move into the air. Now, sodium chloride by a less concentrated hydrochloric acid. Look at this is a salt of a volatile acid. Take note. A salt of a volatile acid. If hydrogen were to be here now, this is hydrochloric acid, which is volatile, and this is a less strong acid. Take note. It has been a bit from the statement here. Stronger and less volatile acid displays weak and more. This is a strong acid, but less volatile. So from there, see what the result is. It produces another acid and a salt. So this is another way of preparing an acid. Let's move on to the next one. Dilute hydrochloric acid displaces the weak triisocarbonate 4. This is another way of preparing acid. This is a dilute hydrochloric acid. This is a salt, but this one is displacing the other one. So that is why we have, in this case now, this is a metal. In this case, this is a metal. This is a metal. This is regarded as radical. So when this hydrogen combines with this radical, it gives H2CO3. And this chlorine combines with this calcium to give calcium chloride. Please take note of that. Take note, take note, take note. Let us move on to the next slide. Note, hydrogen chloride gas dissolves readily in water to form acid. When you have a gas, hydrogen chloride gas, it's a gas, but when it is dissolved in water, it forms an acid. Let's pause it here and we shall continue. Thank you.